Hello, welcome to this live technical discussion related to draft standard of IS 1893 Part 4. So we have received very interesting discussion point through registration form, almost 200 points. And certainly we would like to arrange more discussion on this area. But in today's session, we will be focusing our discussion mainly on the changes whichever are made or rather proposed in this draft standard. So whenever we are talking about industrial structures, then industrial structures are highly irregular, and that's why they are relatively more vulnerable in the seismic events. And for that, this IS 1893 Part 4 was firstly published around 2005. Then it was revised in 2015. And now there are certain changes which are proposed in this document. So in today's session, what we'll do, I've just compared the two documents. One is the current IS 1893 Part 4, which is 2015 version, and this draft standard, which is published by BIS Technical Committee. So I just try to compare both the documents, and then I've highlighted important points. So those important points I'll be sharing shortly after a few minutes. Meanwhile, you can also share your finding, or let's say your understanding, or let's say your questions related to this draft standard through this chat box. And then towards the end of the session, we will take up the points whichever you are mentioning through the live chat. So you can just to start with, at least you can mention in the chat box whether you have referred this draft standard. You can simply mention yes or no in the chat box. And link for the draft standard, which is published by Bureau of Indian Standard, is available in the video description. As well as we also arranged one of the live discussion exclusively for IS 1893 Part 4 2015. It was scheduled on in the September month 2022. So that discussion is also available if you would like to see. So in that we try to understand different components or different important aspects of IS 1893 Part 4. So in today's session, we will just try to compare both the standard, like the existing standard and the proposed changes, whatever have been made in this draft standard. Okay, so I've just highlighted the few important points which I have gathered based on referring both the documents. So these are just only points which I could highlight. So that is quite possible that there may be many other points in this document. So I'll just share the quick summary, or let's say quick highlight of the points whatever I have observed. Okay. Yeah. Okay. Yes. Thank you, Agraj. Okay. So just let me share the screen just to start with. So now I'll be sharing the entire document on the screen. Okay, so this is the document which is published by Bureau of Indian Standards. And the last date for comments is 2nd April 23. Okay, so it's very much important that we highlight the important points, and then we send to Bureau of Indian Standard for their consideration in this draft code. Because once the code is published, then it's very difficult for getting it revised, or there is a lot of problem while doing the proof checking consultant. So this is the format in which we can send the comments. Okay. So in this document, I've highlighted important points which I have noticed while comparison of both the documents. So this is not a complete summary. It is just based on my findings. So as I just mentioned, that there could be many other points. So in the initial part, it says that there are certain formal clauses which will be included. Okay. So out of this, it was already there, but I have highlighted few important points here. That clause number 1 to 6 of part 1 of the standard represent general provisions that are applicable to all types of structures covered in part 1 to 6. So, in the part 1, IS 1893 part 1, the clauses 1 to 6 will be applicable to all different parts, like part 2, part 3, part 4, part 5, part 6, etc. Okay. And as we just discussed, this code was firstly published in 2005, then it was revised in 2015, and now it is the sixth revision, which is for which these changes are proposed. So this list shows the significant changes which have been incorporated. So let's quickly go through this. The definitions of various terms are added for the earthquake engineering and industrial structures. Design spectrum for industrial structures and for stack-like structures, it has been updated in the figure number 1 in the annexure or in the last part of the code. Importance factor for category 3 is revised. Then now there is new inclusion of maintenance specific imposed load, which is MSIL. So it has been introduced to address long maintenance period where the loads as well as structural configuration may be different. Okay, so we will see this revision. Then industrial structures have been categorized in detail. So earlier in 2015, if you, as you must have seen, that there is just only table 6. Now there are table 6 to 8. So there are total 3 tables: table 6, 7, and 8. Effect of masonry infill walls and stiffness considerations are included. Then consideration for temporary structures or facilities are brought under the purview of this standard. And then specific provisions for different structures is now included, like ground supported vertical cylindrical tanks, then structural considerations during maintenance, anchorages, crane supporting structure, bunkers and silo, and then pre-engineering structures. So specific provisions for these structures are also included. So apart from that, there are many other changes which I have noticed and I have just highlighted. So firstly, it says that these provisions of earthquake resistant design of equipment and piping are under development. So we will expect now the new version or new document which will include the seismic qualification for equipment and piping. So till such time, it is said that this part 4 will remain or shall remain applicable. Okay. Then in seismic zone 2 and 3, the temporary structures, let's say as a scaffolding, temporary excavations, structures or equipment needed during a scheduled shutdown or maintenance period. So at that time, if this structure is, let's say, for a limited time use, for example, not exceeding 1 year, then it need not be designed for the earthquake force. So what it says that if building is, or rather temporary structure is situated in zone 2 and 3, and it is meant for time which is not exceeding 1 year, so in that case, earthquake force need not be considered. But if the temporary structure is situated, let's say, in zone 4 and 5, then this temporary structure shall be designed as category 4 structures. And in any case, the temporary facilities or structures that may be in service for longer than 1 year shall be designed as permanent structures as per provisions of this standard. So this text are now added. Now, this standard shall be considered applicable to structures of all industries, including this listed below. So this all list was already there, but you can just refer to this. And also, it's also applicable to the stack-like structures, right? Now, when we come to the terminology, the most important or one major change which is made, that now definition of design basis earthquake and maximum considered earthquake, that is DPE and MCE, is now removed from this entire document to make it in line with the part one document. So as you may be aware that in part one DPE and MCE is removed. So from the terminologies also this DPE and MCE is removed. In the maintenance specific imposed load, now this is the new definition added here. It's a load imposed on a specified floor area for maintenance and repair operations. So this is the definition which is now added. Okay. Now, when we come to this para number 6, so it is rewritten actually, which is the inertia force. So what it says that the effect of earthquake-induced vertical shaking can be significant for overall stability analysis of structures, especially in the structures with large spans and those in which the stability is the criteria for design. So what it says that the reduction in gravity force due to vertical ground motions. Let's say if you are applying vertical earthquake force on these structures, then it could reduce the gravity force also, right? So in fact that would be detrimental, particularly in the pre-stressed horizontal members or let's say cantilever members and gravity structures. Hence, special attention shall be paid to effect of vertical ground motion on the pre-stressed or cantilevered beams, girders and slabs. Here, the actual ground accelerations that are experienced during earthquake by structures are much stronger than the design acceleration specified in this standard. So, in other words, it can be said that earthquake-resistant design, as per this standard, actually relies on the inelastic behavior of these structures. But the maximum ductility that can be realized is limited, and therefore all structures shall be designed for at least the minimum design lateral force specified in this standard. Okay, so this is general statement. And this 6.1.4, what it says that it is actually talking about ductile detailing. So member and connections of reinforced and pre-stressed concrete members shall be designed to ensure that premature failure does not occur due to shear and bond, or we can say shear or bond. Now here in the text, this modification is made. What it says that only some provisions for appropriate ductile detailing of RC members are given in IS 13920. So in the earlier document, it is said that we have to refer 13920, but now it says that only some provisions are given. Now, similarly, when we refer to the steel structures, again, the same text is added, which says the some provisions are are added for the appropriate ductile detailing of the steel members. So here it is not clear, like then what are the balance provisions which needs to be considered, right? The soil structure interaction, it was already there, but I have just highlighted for discussion that it refers to the effects of flexibility of supporting soil foundation system on the response of structure. And it shall not be considered for the structures which are supported on rock or let's say very hard strata soil. So it means that soil structure interaction will be required whenever structure is supported on, let's say, medium soil or the soft soil, right? Now, how to do the soil structure interaction? So, couple of just only one or two sentences now added in this document in the later part. So, this is a new addition, which is a maintenance specific imposed load, and it says that shall be considered only when the maintenance duration is longer than 10 days. Okay. So when the maintenance duration is less than 10 days, then MSIL need not be combined with the earthquake forces, but shall be separately considered as a superimposed load in the structural design. So if MSIL, which is maintenance specific imposed load, if it is going to be applied on the structure for longer than 10 days, then it shall be considered along with the, or rather it should be combined with the earthquake force. So this is the new addition. Okay, now this is important when we look at the increase in the allowable net bearing pressure on soils in design of foundations. So here entire table is rearranged, rewritten, as well as few modifications are made here. So if we just quickly look at this table, in the first of all, it is divided in a two tables, like table 1A and table 1B. If you refer 2015, there was only single table, right? So in table 1A, it identifies the soil type. So let's say type A, type B, type C, and then it is identifying the percentage increase, like 50 percentage for rocky strata or hard strata soil, 25 for medium or soft soil, and 0 percentage for the soft soils. Now here a couple of important things are mentioned, that in this entire table, whenever we are doing this soil classification, everywhere it is mentioned that we have to use only corrected values of n. So that means whatever SPT values we use, that shall be corrected values. And for classification of soil, if we just scroll down a bit here, so if you refer in 2015, this percentage of increase was actually defined based on the type of foundation, right? So what is done here in the next part, here all different types of foundations are mentioned, like isolated footings, raft foundation, pile foundation, group of pile foundation, and well foundation. Uh, and what is said here, that weightage average of n of soil layers from the depth of founding to the depth of founding plus twice the breadth of the footing. So what does it mean? That we have to calculate weighted average of SPT, or let's say corrected N value in the influence zone of the particular foundation. So for each foundation, the influence zone is identified, and for within that zone, we have to calculate the weighted average value of N, and again the N shall be corrected value. And based on that corrected value of n, we'll be able to classify the type of soil, and then we have to refer the table number 1A, which we just show in the previous page. So for the route foundation, the weighted average of n of soil layers from depth of founding to the depth of founding plus twice breadth of the raft. So similarly, for all different foundations, the influence zone is identified. So based on that, we have to find out weighted average n value. Again, n shall be corrected value. And this table 1B represents the classification of types of soils for determining the percentage increase, or let's say percentage increase in the capacity of soil in the net bearing pressure and the skin friction. So it is divided in three parts: type A, type B, and type C. So when you compare these this word to word, you will notice that here here changes are made in the description. In this description, the changes are made. Okay. Okay, so you can just refer this part. So what is the main purpose here? What changes I'm highlighting, that you can just go through these changes, and if you find is there any practical difficulties which could be encountered, or let's say if you find any ambiguities, or you find that this clause is not appropriate, then please write to Bureau of Indians Standard. The comments can be sent up to 2nd April 23. Okay. And for this type D, which is the new category added, which is unstable, collapsible, and liquefiable soil. So, of course, it will require site-specific study and special treatment according to the site conditions. This is again I have highlighted here that here N in the entire calculation, the N is the corrected standard penetration test value after ground improvement if it is required. Now, for the design spectrum, which is one of the most important part of this document. So, as I just mentioned in the earlier part, that now concept of DBE and MCE is removed from this document. So, accordingly, the relevant paragraphs of this documents are updated. Here it says that for all important industrial projects and all industries dealing with the highly hazardous and toxic chemicals, evaluation of site-specific spectra is recommended, and such site-specific spectra shall be considered as design spectra. So here the DBE and MCE concept is removed. And here, that's why here for site-specific spectra, these note is added. So what it says that the site-specific spectra shall be generated for an earthquake with minimum return period of 475 years, or with probability of accidents of 10% in 50 years. So since the DBE and MC concept is removed, so that's why here it is clarified that when we are doing this site-specific spectra, so that spectra shall be generated considering the minimum return period of 475 years, or with the probability of exceedance of 10% in 50 years. So the equation which we will utilize is AH into SA by G. So here SS is mentioned, which is site-specific spectra. Otherwise, equation is same. Okay, this is one more change which I could locate here, that importance factor and the response reduction factor are to be taken from the table number 3 and 4 respectively. Here one note is added here, that for ratio I by R in no case be larger than 1. Okay, so that's obvious that we will not have this value larger than 1 in any case. Okay, for vertical seismic coefficient, now the reference is given to the 6.4.6 of part 1. So we need to refer IS 1893 part 1. And as it is mentioned in IS 1893 part 1 in the latest amendment along with the document, that vertical earthquake force will be required for almost all kind of structures. So similarly for the industrial structures also, vertical earthquake force will be required to be considered. Now, in this document, IS 1893 Part 4 2015, as you all know, that all industrial structures were put under different categories, right? So in this para number 8, different categories are identified, like category 1, 2, 3, 4. And in this section, the definition of a category is amended with one more note. So for the category 1, this second para is added, that structure that support components and equipment whose failure can cause conditions that can lead directly or indirectly to extensive loss of life or property to the population at a large in the areas adjacent to the industrial facility. So in the first para, it was only addressing the structures. Now in the second para, it says that the structure which support the components or equipment which can lead to extensive loss of life or property shall be considered in the category 1. Similarly, the paragraphs are added in the category 2, that now structures that support components and equipment that do not fall in category 1 and whose failure can cause conditions that can lead directly or indirectly to extensive damage within the industrial facility. Right? Now, for the category of structures, earlier or in 2015 document, we have just only table number 6. Now, total 3 tables are added. So table 6 is already there, and table 7 is added, and table 8 is added. So now there are 3 tables for the categorization of industrial structures. Yeah, this is one of the important point I've just highlighted here. What it says that equipment supported on a structure can have multiple operational scenarios, such as it can be empty, partially full, or let's say completely full. So these operational scenarios may result in mass irregularities that shall be duly accounted for. Okay. And in the last line, it says that in case of multiple equipment supported on a structure, various possible combinations of operational conditions shall be considered. So in my opinion, it will require, right, so many permutations, combination of considering different equipment in a different conditions, like let's say partially full, completely full, etc. And then again, if you have multiple equipments, so I think this para can be revisited. And maintenance specific imposed load, so that should be considered as per the earlier paragraph. And if there are any other loads, like let's say the temperature changes, or let's say soil and hydrostatic pressure, etc., accidental loads, then that shall be referred as per 875 part 5. So this paragraph is now added here. Okay, this is table number 2, says it's very important part of this document, which is talking about earthquake force estimation, methods of analysis, and design for various categories of structures. And since 2015, this is one of the point of a discussion, that this how to perform this non-linear time history analysis for verification of the collapse mechanism. So of course we attempted this in a number of projects. So let's say if you are interested, you can just contact me separately how this can be done. Of course, it's not detailed out in this document, but in this revised, or let's say in this draft standard, it is just only this note is mentioned that specialist literature shall be referred for nonlinear response history analysis for verification of mechanism wherever required. Then this load combinations. Okay, so I have just highlighted the the paragraph or the text where I could notice there is some changes. Okay, partial safety factor for load due to pre-stressing effect shall be as per IS 1343. If pre-stressing effect is there in the structure, then we need to consider the partial safety factor as per IS 1343. And this is same, which is combination of different earthquake forces. This paragraph is added that the combination of procedures which is outlined above in the earlier clauses apply to the same response quantity, say moment in a column about its major axis or story shear in a frame, due to different components of the ground motion. and this combination shall be made at the member force or the stress level. So this paragraph is added. And other loads in accordance with the document 875 part 5. For the importance factor, the this value is revised. Like for category 3 structures, if you refer 2015, then this value is 1.25, but here it is updated as 1.20. And response reduction factor for the industrial structures and stack-like structures. So here the table is combined for the industrial structures as well as for the stack-like structures. In 2015, there were two tables. Now here, both the tables are combined. Okay. And a few provisions are added, like let's say the flat slab, which is a two-way slab without beams. Then in that case, response reduction factor is 2.5. And structures which are designed to remain elastic, for those structures, the R value is 1. And then for all other stack-like structures, the values are now added in this table only. Okay, so you can just refer this. Okay, there are few notes added, so I just highlighted which were different than part 4 2015. That flat slabs, two-way slab without beams, as a part of lateral force resisting system are permitted only in the seismic zone 2 and 3 for buildings with height less than 20 meters. So if you want to go, or rather if you want to use the flat slab for the industrial structures, then the height of the building shall be less than 20 meter and the seismic zone shall be either 2 or 3. The eccentric braced shall be used only with the SBF's frame. Okay. Then one more note is added that the structure or equipment not defined in the table above shall have the R value based on the strength, safety, redundancy, and ductility requirement, keeping its usage or let's say the earthquake damage level in consideration. So it defines the methodology in a general context, that how we can derive the R value. And this one more paragraph is added, which is classification of silo as follow. Like it defines silo in different category, like slender silo, squat silo, thick walled silo, thin walled silo, and different criteria are given here. And it also says that for silos supported on moment resisting frames or on frames with bracings, and for casting place concrete silo which are supported on concrete walls continuous to the foundation, R values defined in the above table for the corresponding structural system shall be considered. Okay. So you can refer this table and then compare with the part 4 2015, and you can send your input to BIS if any. Now for the mathematical modeling, there are a few important changes made here. So one note is added here: the mathematical model of the physical structure shall include all elements of the lateral force resisting system, obviously, and then also the model shall include the stiffness and strength of the elements which are required for the distribution of forces. Now this is one of the major change which is done here, that the effective moment of inertia, that means the stiffness modifier, which was introduced in IS 1893 part 1. So those stiffness modifier for RC structures shall be considered as per IS 1893 part 1. Now this will bring potential difficulty according to me, because once we introduced these stiffness modifier, actually our industrial structures will become quite flexible, because we are introducing those fictitious amount of correct moment of inertia. Now specifically for the industrial structure, there is no upper cap or there is no defined limit for the time period. And because of that, the structures will become extremely or quite flexible. So I strongly believe that this paragraph should be revisited, and if it needs to be introduced, then few more considerations needs to be mentioned for specifically for the time period of the structure. For soil pile interaction, it says again that the specialist literature may be referred to include this effect. But it makes this statement also that maximum reduction. So whenever we are performing soil structure, or let's say soil pile structure interaction, then it could bring down the base shear, because it may result into the higher flexibility, relatively higher flexibility in the model. So it defines that maximum reduction in the base shear on account of this soil structure interaction shall not be more than 20% of the base shear of the fixed base structure. Right, so this is one more change, or rather paragraph, which is added. So for that, a couple of more models we need to create. For the one model, we have to consider as a fixed base. We have to derive that base shear. Then we have to compare with the soil structure interaction, and then the base shear needs to be calibrated if it is reducing, let's say, beyond 20%. Okay, and here in the design base shear, okay, it is adding the concept of masonry infill. So if masonry infill walls are added, or rather present in the structure, then couple of paragraphs are added in line with IS 1893 part 1. So what it says that these walls will contribute to the in-plane stiffness of the structure. So that's why it is suggesting to create two different mathematical models uh, for the design. So in the first mathematical model, the stiffness of infill wall panel shall be accounted and modeled as a diagonal struts as per part 1. And this model shall be used for estimation of the natural period and story drips. So what will happen once we insert infill panel into the structure will become quite rigid, time period will reduce, and the seismic force or the base shear will increase, right? Thereafter, we have to create another model, which is the second mathematical model, for which shall represent only the bare frame structure, that is without infills, and shall be used for the estimation of forces in the structural members. Because if we have modeled the infill brick wall or the diagonal struts, and if we analyze that structures, we will not get any forces in the beams and columns. So in the second model, we have to consider as a bare frame structure, and we have to apply the same base shear what we derived from this model number 1. Okay, so that same base shear we have to apply in this second model, but without consideration of infill brick wall. So that's what it says, this two paragraph. Damping is always a point of a debate since 2016 when part 1 was released, because in part 1 it says that damping is 5% for irrespective of any material of construction. But when we refer to this draft standard, there is no change in the damping value. Damping value is still different for different material. Like let's say for the steel, it is 2%. For concrete, it is 5%. So this is where I think one input can be given from our side. And couple of notes are added for the damping also, that the estimated composite model damping values when using materials which are listed in table 5 shall be limited to 20%. So that is the maximum limit of damping, which is 20% of critical damping, even when soil structure interaction. effects are considered. Then the damping ratio of water and other liquid container in tanks shall be considered as a 0.5 percentage, and the damping ratio for the granular materials contained in tanks and silos shall be considered as 10 percentage. And if you refer to this table number 5, so here we can see that for the steel structure, damping is 0.02 or 2 percentage, and for the reinforced concrete, it is 5 percentage. So here you can see that again, concept of DBE and MCE is removed. In 2015, the damping values were defined for DBE and MCE separately. So this concept is now removed. Okay, when we come to the dynamic analysis, this is one of the para where minor changes there. Okay, so those category 4 structures which are identified as buildings and whose failure does not affect plant performance. Okay, so the line which is added for the category 4 structures, that whose failure does not affect the plant performance, shall be analyzed and designed in accordance with the provisions of IS 1893 Part 1. For the detailed analysis, okay, there is a change made in 2 notes, like all industrial structures shall be designed using linear analysis, and all deflection and drips are also limited as per the linear analysis approach. And the requirement of flow response spectra is highlighted for design of let's say piping and equipment in this paragraph. This is the response spectrum method. Of course, response spectrum method is having a number of limitations that we can discuss separately. This is the torsion. Okay. Then for separation between adjacent units, the equation is now updated like this. Okay, now this equation is updated like square root of R1 delta 1 square plus R2 delta 2 square, where R1 is the response reduction factor of building 1, building 2, like R1, R2, and delta 1, delta 2 is the displacement. So delta separation we'll get from this equation. And so this equation is now added here. For foundation, the isolated RC footings without tie beams or unreinforced strip foundations shall not be permitted in soft soil. So whenever there is a soft soil, then isolated footing without tie beams or unreinforced strip foundations are not permitted in any seismic zones. Use of foundations that are vulnerable to significant differential settlement due to ground shaking shall not be used for structures in seismic zone 3, 4, and 5. And in seismic zones 4 and 5, individual spread footings or pile caps shall be interconnected with ties. It was already there in the previous version also, except when individual spread footings are directly supported on the rock. And for all the ties that shall be capable of taking this H by 4 times the force. Now, one line which is added here, subjected to a minimum of 5% of the larger of the column or pile cap loads. Here AH is as per 7.3.1 or 7.3.2. So this AH over 4 requirement is already there in the existing standard. And here in the last part of the paragraph, it mentions the minimum requirement, like 5% of the larger of the column or pile cap loads, which needs to be considered for design of tie members. Okay, and here it says that wherever piles are provided, this shall be designed and constructed to withstand the effects of maximum response included in the part of the structure above the foundation under earthquake ground shaking. And design of anchorage of piles into pile cap shall be consider all combined effects like that axial forces due to uplift and bending moment due to fixity of pile cap, etc. Okay, for the cantilever projection, I think this last line is added like in the analysis of the structure, the weights of these projecting elements shall be lumped with the roof weight. Okay, then if we go to the, okay, this is one more addition, which is non-structural elements in the industrial structure. So what it says here, specialist literature shall be referred for earthquake resistant design of non-structural elements, NSE of industrial systems such as cable trays, bus ducts, HVAC, ducting, piping, etc. The provisions given in IS 16700 also may be used. Okay, so this is a new addition. Of course, it is giving reference to the specialist literature, but it will require a lot of other calculations and separate work for establishing that non-structural elements are also safe in the seismic events. So of course, this actually needs to be detailed out. There should be a complete separate chapter or document on this so that we can consider it effectively. Right. Then there are additional provisions for a few different structures now for which are added now. So one of them is the crane supporting structure. So here it is clarifying a few things like while evaluating earthquake ground shaking effects on the crane supporting structure in horizontal direction, the seismic mass of cranes and trolleys without payloads shall be considered. So that means we will consider cranes or trolleys in the park condition. They will not be considered as, in the operation condition during seismic event. And these payloads shall only be considered for the effects due to vertical shaking. In case of more than one crane in a bay or in parallel bays, the design shall consider a load combination with all the cranes unloaded and parked at the most unfavorable position. Okay. Then for a liquid storage tank, for seismic design of liquid storage tank in an industrial structure, its category shall be as per table number 7, earlier table. Table number, okay, now the table will follow in the subsequent pages. And the importance factor shall be as per table number 3, which was mentioned in the earlier table. And the design shall be carried out as per IS 1893 part 2. So this is for seismic design of liquid storage tank in the industrial structure. In the next para, it says that for the seismic design of ground supported flat bottom liquid storage tanks, which are not covered by IS 1893 part 2. So specialist literature shall be referred for the same. And for such tanks, the category shall be as per table number 7 and the importance factor shall be as per table number 3. Then foundations and footings for mechanically anchored flat bottom tanks shall be proportioned to resist peak anchor uplift and overturning bearing pressure. Overturning stability shall be evaluated for uplift due to seismic moment, and the factor of safety against overturning stability shall be at least 2.0. And content weight and soil load directly over the ring wall and footing may be used for the stability, or let's say to resist the maximum anchor uplift on the foundation, provided that the ring wall and the footing are designed to carry the eccentric loading. Then the next para, it is identifying requirements for the anchorages. So the anchorages design shall be based on ductile design philosophy, and common types of concrete and steel failure modes for anchors are due to brittle failure, like failure of the concrete part considering concrete breakout strength of anchor in tension, pull out strength of anchor in tension, side face blowout of concrete, then bond strength of adhesive anchor in tension, concrete breakout strength of anchor in shear, or concrete pry out strength of anchor in shear as applicable. So here it is just identifying the probable mode of failure when brittle failure occurs. In the next para, it's talking about the ductile failure. That failure of the anchors based on steel strength of anchor in tension and steel strength of anchors in shear. So the following shall be ensured in the design of ductile anchorage system. Firstly, the anchoring capacity of the concrete shall be greater than 1.2 times that of the nominal tensile capacity of the anchor bolt. Then anchor bolt shall be designed for tension, shear, and combination of shear and tension. Out of these, the design shall be made to govern by tension criterion. So second line is not very clear to me. And then the C, in the para number C, it says that the friction between the base plate and the foundation shall not be considered in the design of anchorage elements while transferring the shear forces to the foundation system. And it says that the specialist literature shall be consulted for calculating the concrete anchor capacity. As it is mentioned that we have to consider the capacity as at least 1.2 times. So that capacity should be calculated as per the specialist literature. Then structural consideration during maintenance, because in industrial structures always maintenance is one of the key area. So what it says that in industrial structures, the key structural elements that are part of seismic force resisting system may be required to be temporarily removed as dictated during, let's say, maybe for erection, replacement, or let's say for maintenance, etc. Now, such removal of structural elements may result in change in center of stiffness, leading to alternate load path for resisting the seismic forces than originally it is designed. So, for such structures, seismic analysis shall be carried out for both the conditions, that is, with and without removal of these key structural elements. And further structural stability shall be assessed under both these conditions. Okay, so this paragraph is added now. For bunkers and silos, the requirement shall be as given here under, like categories are indicated in table number 7 and 8 for the bunkers and silos are applicable to all RCC and steel bunkers and silos, as well as RCC silos supported on RCC frame and RCC shaft. Silos and bunkers shall be designed to withstand the seismic forces, considering the full range of material loading from empty to full. Then the effects of earthquake ground shaking in the supporting structure shall be estimated, assuming that the particulate contents move together with the silo shell and modeling them with their effective mass at their center of gravity. the effective mass of at least 80% of the total content mass shall be considered while determining the seismic force, and the unit weight of stored material used for computing seismic force shall be same as that used for all load calculations. So these requirements are now added for the bunkers and silos. And this is one more major change which is proposed here, which is for all pre-engineered steel structures. So always this is a point of a debate and discussion every time we come across with this pre-engineered steel structure. So here it mentions very clearly that pre-engineered steel structures, for example PEBs, shall be checked for adequacy against earthquake effects as per the provisions of this standard. Steel design and detailing, member sizing, check for deflections and minimum member thickness shall also conform to IS 800. And for loads and load combinations, we shall refer IS 800 or IS 1893. Okay. So now from this table number 6, in the table number 6, it is identifying the categorization of industrial structures. So in part for 2015, it is just only one table in which categorization or different categories of industrial structures is identified. But here, now the categories of industrial structures is added in 3 tables. So first, this is first table, which is table number 6. So we can see different structures are added. So you can refer this table and then you can share your input related to this. So if you just quickly look to this category, like first of all, this is main plants and the process plants under which all the different structures are identified. Then type B is for the utilities, for that means structures for different utilities are identified in this part B. Okay, we can see all structures for different utilities. And then when we scroll down, then we get into the storage and handling. So part C is talking about storage and handling, like let's say catalyst storage building, chemical house, pipe rack, etc. And part E is the infrastructure type of a building, like administration building, canteen building, etc. So this is table number 6. Now 2 more tables are added. So this is table number 7, which is talking about categorization of industrial stack-like structures and ground substructures. So again, it is divided in different categories or different headings. So first is the part A, which is the main plant and the process plants, including, let's say, power plants, hydrocarbon plants, chemical, fertilizer, metallurgy, etc. So here we can see different equipment like cock drum, HRSG stack, process column, reinforced brick machinery chimney, silo, etc. Then in part B, it is covering different utilities. That means equipment which are associated with different utilities. Then for storage and handling, which is coming under part C. And finally, there is a table number 8, which is talking about categorization of vessels, equipment, and piping. So that is also defined in several parts. So first is the main plant and process plants, like power plants, hydrocarbon plant, etc. So it includes bagging and pelletizing equipment, boiler, converters, heater, etc. And categories are always mentioned for all different items. So you can refer to these tables in detail and you can share your input if any. So part B is for utilities, and in utilities all different equipments, or let's say vessel, equipment and piping is added here. Then storage and handling. And then the section 2 starts with the stack-like structures. So in stack-like structures, the damping ratio for different material to be used as determined in the table number 5. So it is same table which is referred, which we just saw during earlier discussion. Otherwise, I could not locate any major difference. But if you find out anything, then you can share it with me. Or let's say if you have any comments, you can share directly with the PIS. So these all texts generally I find almost similar. The deflection criteria, okay. This is the annexure A, which is cross referred standards. And this is the table number 14 for multiplying factor for obtaining the values for of SI by G for other damping ratios. Like for 5%, this value is 1. And for 2%, like let's say for the steel structure, this value will be amplified by 1.4 times. So these anomaly still remains between two standards. Like part 1 says that damping is only 5% to be considered, but here again the damping value is different even in the revised standard or in this draft standard. And this is the last part of the document. So in this annexure C, the design spectrum is now updated, and it is mentioned for different type of soil like type A, type B, type C. So this is natural period time, and this is SI by G. Okay. Okay, so with this, we come towards end of the document. And then finally, this decoupling criteria is added for the category 1 structures. Okay, so it is almost similar. Okay, so this was quick study of the document. So based on my quick study of both the documents, I have highlighted a few points, and those points we have discussed. Okay. So you may share the let's say any points or queries or doubts you have through the chat box. Okay, and I'll suggest that you can still go through this document in detail. The comments are to be sent by the 2nd April 23, which is the last date. So still, if you have any problem, or let's say any discussion point, you can always contact me, and then we can discuss it further. And let's say it would be great if you can share your input, your comments to the BIS technical committee, so that the possible changes, or let's say during the revisions of the document, the required modifications can be considered at the right time. Because once the code is published, then it's very difficult to get it revised, right? Okay. Okay. And through the registration form, we have received very interesting points related to earthquake resistant design for the industrial steel structures. Of course, they are not in line with the revised draft or the proposed draft. So for those points, definitely we will plan the next, or let's say separate session for discussion related to those points. Okay. So meanwhile, let's spare few minutes if you have something to say. If you want to share some additional points before we close this session, you are, please feel free to share anything through the chat box. So whenever we are doing earthquake resistant design for the industrial structures, it is substantially different as compared to the building types of structures, right? And so that's why when we compare IS 1893 Part 4 with the Part 1, we can see there are substantial changes. Right? And it happens, let's say, if certain clauses are ambiguous, then there will be a lot of to and fro which will happen with the proof checking consultant. So in this document, I've just highlighted the points for which I could locate by study of both the documents. So it's quite possible that I might have missed out, a number of points. So you can still look from that perspective, and then please feel free to share your comments, doubts, etc., to the BIS technical committee. So one of the important point what I have gathered from this document, or let's say while designing the industrial structures, what I have found that consideration of time period is very important. Because let's say in a part 4 it is mentioned very clearly that we need not scale up the earthquake force, right, as compared to the IS 1893 part 1, because it is not possible to derive a single or a simple formula which can demonstrate, or rather which can calculate the time period of such a, let's say, irregular industrial structures. And that's why it is said that we need not scale our earthquake force with reference to IS 1893 Part 1 formula, time period formula, because the formula which is mentioned in a Part 1 is for building type of structures. So now in Part 4, what happens whenever we are creating model for dynamic analysis, and let's say, for example, if our modeling of stiffness or mass is not appropriate, not correct, then many a times we have seen that the time period what we get is substantially lesser than actually it should be. And there is no limit of the time period, like this shall be the minimum time period for this kind of structure. It's not there. Now, over and above that, in this proposed draft, it is mentioned that stiffness modifier needs to be considered. Now, once we include this stiffness modifier, this will again further aggravate the situation, according to me, because structures will become more flexible, and we do not have any defined cap for the time period. So I think that para needs to be revisited. Okay, so if you have any question, any points, can mention through the live chat. Or let's say after finishing this session, the video will be published. You can contact me separately also. Okay, so thank you all for attending this session. And I'm sure at least you would have got some insight about this draft standard. So overall aim for arranging this session is to apprise you all about the revisions which are made in this standard as per my understanding. And secondly, to encourage you all to send your input, your valuable input, comments to the BIS technical committee, so that it can be considered while formulation or while finalization of this very, very important document for the design of industrial structures from the perspective of earthquake resistant design. So with this, we are closing this session, and then we'll be meeting very soon with the very interesting live discussion shortly. Okay, so we are signing off now. Thank you. Bye.